Today we made a connection between limits and average rate of change, and recognize that limits that look like this that we worked with in Unit 3 are actually representing the average rate of change of the function square root x as the x value gets really close to 9. So if we look at the function square root x, right, here's our point 9 comma 3, input 9, output 3, okay? This is our varying point, right? This is our point that's going to approach x equals 9. So as this point gets really, really close to the green point, we're not going to have an average rate of change anymore. We call this our instantaneous slope, right? Instantaneous slope at x equals 9. Okay, we can find that instant slope by letting the 2 points become really, really close together. And we already know how to solve this algebraically. There's videos about that, but we did it a lot last unit. We find out the answer ends up being 1 over 3 plus, or sorry, 1 over 3 plus 3, which is 1 over 6, right? So what that means is, at this green point, if we were able to draw a straight line, I'm not even going to try on this video, but if we could draw a straight line that only goes through that green point, the slope of that line would be 1/6. And how we can approximate it is, well, we could find the average rate of change between the blue and the green point. But then we can move that blue point closer and closer and closer and closer and closer and closer. That's the idea of this limit. So our slope formula ends up being the limit as x approaches c of f of x minus f of c over x minus c. Okay? X minus c. So the point that we're drawing our tangent line through is c comma f of c, whatever this x value is, whatever our f of x is, right? That is our point where we're drawing our tangent line. This is a varying point that's going to get really, really, really close to our fixed point. We're going to let x approach c to the point where it's basically right on top of it. And once the points are right on top of each other, when we draw a line between them, we don't have an average rate of change anymore. Instead, we have an instantaneous rate of change. So if we look at this example, we have f of x is 1 over x plus 2. Right? F of x is 1 over x plus 2. That's the function that we're working with. And we're trying to find out the slope of 1 over x plus 2 at x equals 5. What's our y? Our y is 1/7, right? So this is f of x minus f of c over x minus c. And if we can simplify this limit, we'll find out the slope of 1 over x plus 2 at that point. And again, I'm not going to do the algebra in this video, but what we end up getting is this will simplify down to negative 1 over 7 times x plus 2. And if we plug in our limit, x approaches 5, right? Plug that in. We're going to get negative 1/49. So that tells me that the function 1 over x plus 2 is decreasing at x equals 5, but it's not decreasing that quickly. It's pretty flat because negative 1/49 is really small. It's like close to 0. And that's the idea with these limits, is it tells us the slope of the function at the point that we're plugging into our instantaneous slope formula. So when you look at this formula, what you should be thinking is, this is a fixed point. We're trying to draw a tangent line through that point, and this is a varying point. What's happening to this point is it's getting really close to the other point, so that when we draw our line between them and find our slope, we're actually, instead of finding an average slope, we're going to find an instantaneous slope, instantaneous rate of change.